Yeah. Am I audible to people who are online?
Yes, sir.
Okay. So did you solve problems based on rotational mechanics in the previous class? So can I check someone's notes? Who all attended the previous class? Hmm. So how many problems did you do? 3 plus 4. Total of 7 problems, right? Okay. So this topic is over then. Did you do these problems? Yes or no? Can I ask you how you did? So how to do this problem? You didn't come for the past? நான் நடத்தல இது வந்து recordings தான். I asked you to go through the recordings, no? This concept I taught separately in the. Did you go through the recordings completely? Yeah. What is it? Half? Correct. So it is half I omega square, where I stands for what? What inertia? So can you tell me what is the significance of moment of inertia? Let me see. Whatever you understood. I'm not very particular that you have to tell me exactly what I taught. What is the significance of? Did you watch all the lectures in the order? No. Only 2. Did you? ஒண்ணுதான். பாத்தியா எல்லாமே எது பார்த்தோமே? I'm asking about moment of inertia. I would have used this pen only as an example and explained it. I would have rotated also. பார்க்கல. Why? At least now you could have gone through, no? Then how did you understand, or how did you follow the previous class problems? What happened? உனக்கே நீ ஏன் பார்க்கல? ஆமா சரி சரி அட்லீஸ்ட் இந்த வாரம் பார்த்துருக்கலாம். ஓகே அதனால பார்க்கல. I told you the reason also why I'm giving those videos. What did I say? I'm not getting time to solve problems. And mostly you people, you yourself know, I need not tell you, half of the year is over, right? What is bothering you, concept or problems? Then, right? Then you need help with it, you have to do some homework and come, no? In fact, I was supposed to give this video, this week's recordings also. Did you see the monthly schedule that is being shared with you? Everywhere I wrote only problems. Meaning, I was expecting you to go through the content and come to the class, So that I'll concentrate more on problems and it will make more sense also. Trust me, you will actually do better. I'm not telling it for my sake, okay? I'm not telling to push saying that you have to go through the video and come or something like that. I have done this, it has been proved, and I'm giving you that. I'm 200% confident if you do that as a practice, at least do it for 2 weeks and see. Third week, you will not find physics as tough job at all. Since this is the first time, it's okay. I'm leaving it because I told you in the last minute only. But at least from next week, okay, I'm spending so much of time. That 45 minutes video which was given, I recorded for at least 1 hour 15 minutes. Last week, Friday, after your class was over, I was here till 9 o'clock. I recorded, I gave it and went because I had a sudden meeting. I had to go and I didn't want you people to struggle. Is that clear? Or else we would have lost 1 more week and half of the time is already lost because of your school exams. That's why I'm very strict this time. No classes will be cancelled. Okay. So can I expect, I'm not going to speak much. Can I expect next time onwards, you will do your work and come to the class? You know how to do it, right? What is it you're supposed to do? Can you tell me? Look at the monthly calendar. Whatever is going to be held for the previous next week, you will have the videos in your app in the previous week itself. Okay. So this week I've targeted to complete this chapter. But I'm not sure because I have to teach the theory now. I don't know if I'll be able to complete and meet the target. But I'll try to record the videos for the gravitation chapter and give it to you because if I start teaching you, it's a waste of time. Trust me. I'm sure you're not coming here for theory because theory already you're learning in school also. Yeah, understood or not, that's a different story. I'm not talking about it. But at least to understand that, I'll give you the videos. But problem, somebody should help you, right? Somebody should guide you on how you're supposed to think, especially MCQ, assertion reason based questions. How did you do your test this time? Was it easy? I saw the paper, it was easy only, not as tough as you people proposed. How many of you felt it tough? Was it tough? Why? That is a problem. That is what I'm trying to explain, okay? How many of you feel that physics is, it's important for me to discuss, don't think I'm deviating. I want to understand what is the problem. How many of you think that physics is theory subject? For sure, it is not, right? It is not actually. When you told derivations, you had to mug it up, no? I could understand that you have some, I'll be using that word, you have some hatred towards it. Huh? எனக்கு உன்னை பத்தி தெரியும்டா. Holidays, when I did experiments, you came and did it. I know what you can do with physics. Problem என்னன்னா, maybe you're not good with attempting problems. On a concept புரியும் எனக்கு அது தெரியும். உன்னை பத்தி பர்சனலா சொல்லணும்னா I know. But with the answer she gave, she is having, it's not her mistake. It's not your mistake. Maybe the subject was not delivered in the way you wanted it. Right? Sometimes the pressure will also put you in that kind of situation. Even I went through it. Don't worry. Okay. I'm not saying I was born genius. Today I'm teaching because I have experience. I developed interest towards subject. Okay. So I'll just give you my example. You know the concept of slope and all, right? Slope of a line. Slope of a line. Slope. I taught you before differentiation, if you see. I taught you maybe in half an hour to 40. You attended the first class, right? The very first class. I taught slope only because he came and told me that differentiation is being taught in school. So I told differentiation you can't directly learn because differentiation meaning is slope of a line. Okay. I taught maybe in half an hour to 45 minutes. When I was a student of your age, I took 6 months to understand what it is. So you can judge if, because I was not explained the way I wanted. I didn't understand that concept. My teacher came and wrote the formula y2 minus y1 by x2 minus x1, mug it up, next day I'll give you problems, do it. This is what they told. Imagine I'm an inquisitive person, I can't understand things. Without concept, I'll not touch. I'll start hating. I was in the same situation. Okay, but once you crack it, right? Once you become independent, the day you master the art of learning. When I say art of learning, right, it is not physics or something. Art of learning is for anything. Today you are doing all these things for multiple reasons. Okay. So given a chance, I'll be very honest. Okay, you can be very open with me. Don't hesitate. I know your problems. Okay, given a chance, how many of you will? If there is an option that you need not study physics, you need not study math, how many of you will close it off? For sure, you will do it, right? நீ என்ன subject பண்ணுவ அதே மாதிரி? Given a chance, 12th standard in the subject படிக்க வேணாம். You need not read the subject at all. You have in your syllabus, but maths happens. For physics, for sure, it happens. So you're studying for some kind of, you have a society. This pressure is there. No, what is happening is in that pressure, you are putting yourself in so much of trouble that you're actually not mastering the thing that you're supposed to master. I'm telling you why. It's because you ask the right questions, right? You will get the answers for everything. So there is a technique for studying everything. I think I've tried my best to explain it to you. I'm not sure how many of you have actually grasped my way of understanding. At least try to do it. To solve that problem only, I'm telling you very honestly, to solve this exact problem of you having the hatred towards the subject only, I'm giving the recorded videos, because when I teach in the class, some of you might understand in 5 minutes, some might take 50 minutes also. There is nothing wrong. Even if you take 5 days, it is nothing wrong. But take your time, put that effort to understand. All I'm asking is not that you have not understood. I'll never scold that you have not understood. But I'll only question you when you don't make that attempt. I hope you're able to understand the difference. I need that sincere attempt. You do it, one day you'll succeed, I'm telling you. I'm not talking about physics at all. Just because I'm physics teacher standing here, I'm not talking about physics. I'm not vouching for it also. You hate it. That's nothing wrong. But my job is to create interest. Maybe I'll succeed at some point. I might fail also. I don't mind that. But it is your life. Tomorrow I might become a graphic designer. Who's worried about all this physics nonsense? Correct, Danada? நீயே ஒரு ஆர்டிஸ்ட் தானே, உனக்கு ஆக்சுவலா மேத் இருந்தா இன்னும் நல்லா இருக்கும். Maybe if you understand the spacing and everything, that is math only. I'm not talking about integration, complex integration, இதெல்லாம் சொல்லல. But at least basic math is needed. Like negative space பத்தி பேசுவோம் when you design something. So that might help you. Maybe you should understand or try to read it from that extent. Try. Success ஆகுமான்னு எனக்கு தெரியாது. ஒரு பாயிண்ட்ல ஸ்பார்க் வரலாம். புரியுதா? So I'm trying to tell you why I'm doing that recorded videos, because you should not think that sir is escaping from teaching in the class. No, I'm not doing that. Okay, I'm trying to actually save you only. All that you have to do is blindly trust me. At least for 2 weeks, do that and tell me. 3rd week, I'll ask you the report. You give me a feedback. Can I trust from next week? நீ ட்ரை பண்றியா? நீ சொன்ன பத்தி அந்த ப்ராப்ளம் எப்போ சால்வ் ஆகும்னா, go through the video multiple times. Okay, ட்ரை பண்ணு. ஃபெயில் ஆன இதுவானா கூட பிரச்சனை இல்லை, புரியலன்னா பிரச்சனை இல்லை. I'm there to help you. But approach. Don't wait till Thursday or Friday. But சரியா? Okay. So having said that, I'm not sure how many of you know the formula. It is half I omega square, where I is the moment of inertia. Okay, just to explain the summary. Those are online. Am I audible?
Yes, sir.
Yes, sir.
Okay. See, just to explain what this moment of inertia is. What is inertia? Resistance towards what? There are only 2 things, okay? If you want an object to move, what will you do? Apply force. If you want an object to rotate, apply torque. That is rotational force. Okay, so wherever you see the word rotation, there is a grammar for physics also. Wherever you see the word rotation, right? This moment of something will come. This will be as a prefix of something. See, you have already learned what is inertia. So inertia is what you people told that resistance offered by an object to whom? To the applied force. So what will force do? Force will try to move the object, right? If you have a big stone, let's say you have a rock in front of you, you have a small stone in front of you, which one is easier to move? Assuming the rock is completely solid. Obviously, the smaller stone. Why? You apply lesser force, it will move. But for the same lesser amount of force, you cannot move the rock. So it is offering more amount of inertia to the force that you're applying. Means it is saying, I'm not ready to change my state of motion. Am I right? In a similar way, Moment of inertia is a concept which is related to the parameter saying that, which is related to the fact stating that if you want to rotate an object, how much resistance the object is offering to the applied torque. So for you to rotate the object, you need to apply something called as torque. Okay, so moment of inertia is that is the significance of it. And moment of inertia has a formula, I is equal to mr square. I've explained everything in detail. Okay, this weekend ensure you're reaching the target. Okay, close it. So if you take the axis of rotation, if you take this point P, from the axis of rotation to point P, if I take the distance to be r, okay, let's say there is a point mass m that is kept here, and this mass is rotating about this axis. Let's assume this pen itself is rotating like this. Okay, it is rotating in this way. I take a small piece of clay and stick it here. So when this pen is rotating, how is that clay? Pen is in rotation, clay is in circular motion. So clay is in circular motion, right? So well, moment of inertia is defined only for a point mass. Have that in your mind. So what is the formula for it? I is equal to m, where m is the mass of that point mass, and r is the distance from where? And it's not radius. R is the distance from the axis of rotation to the point where the mass is kept. So never remember it as radius, because we don't speak about circular motion. We speak only about rotation. Okay. So what did I say? Mass into perpendicular distance square. I is equal to mr square. Am I clear with this? So moment of inertia is a scalar quantity. Suppose this is m1, this is r1. If there is another mass m2 kept here, and this is r2, what will be the moment of inertia of second particle? Can you tell me? So if the moment of inertia of the first particle is I1 is equal to m1 r1 square. Okay. What is I2? Same. Simple, no? Same logic. M2 r2 square. Similarly, if there is an nth particle which has a mass mn and radius, not radius, sorry, distance from the axis of rotation as rn square, then this is going to be the moment of inertia of individual particles. If all these particles put together form one system, then what will be the moment of inertia of the total system? I will be equal to I1 plus I2 plus so on till In. So what you need to do is M1 R1 square plus M2 R2 square plus so on till Mn Rn square. So are you able to understand? Right. This is what is the formula for moment of inertia of M particle system. M particles. I'm using this word very clearly. So this M1 R1 square is applicable only for point mass. So like that, how many point masses do you have in the system that we considered? N number of point masses. So the moment of inertia of the system is given in this way. Is it clear till this point? Okay. Are you done copying? So listen. Now, when I talk about this rotational kinetic energy, right, there's another important concept. So this rotational kinetic energy is nothing but it's given as half I omega square. I'll tell you how it is obtained. Okay, I'll just do a quick derivation. If there is a system like this, if there is a system which is revolving in this way, imagine a potato. Okay, imagine a potato which is rotating about. Let's assume there is a straw passing through, where that straw is considered to be the axis of rotation, and the potato is revolving. So you will have dots on that potato, right? Treat them as individual particles. Let's say there are n dots. Okay, M2, M3, M4, where each dot is at a distance of R1, R2, R3, R4 from the axis of rotation. Like this, Rn distances are measured. Okay. So I asked you a question. When the potato is rotating, how are these particles? They are in potato is rotating. Particles are in circular motion. Okay. So when they are in circular motion, can I say that there is a velocity associated with each particle? Right. So if I take the velocity of the first particle, if I call it as V1, then V1 is written as R1 into omega. If you remember, I told one important point. Whenever you have a rigid body that is rotating, it has a different linear velocity, but it has the same angular velocity. So every particle will have the same angular velocity. So V1 is equal to R1 omega, V2 is equal to R2 omega, V3 is equal to R3 omega. If you observe, I'm not writing omega 1, omega 2 and all those things. It's the same angular velocity. Like this, what will be the value of Vn? Rn into omega. So what is the formula for kinetic energy? Half m1 v1 square. Right. So this is the kinetic energy of the first particle plus half m2 v2 square. This is the kinetic energy of second particle. Like this, if I write the kinetic energy, what will be the kinetic energy of the nth particle? Half into mn into vn square. Am I right? So half into half, can I take it out? m1 into, instead of v1 square, can I write it as r1 square omega square? I'll just take this and substitute. Plus m2 into r2 square omega square plus so on. So what is going to be the last term? Mn Rn square omega square. So what is common? Omega square. Take it out. So half omega square into m1 R1 square plus m2 R2 square plus so on till mn Rn square. Right. What is this? Just now we saw. Just now we saw, right? The previous slide. This is the moment of inertia. So half into this one is going to be I into omega square. So if you call half mv square as translational kinetic energy, half I omega square will be rotational kinetic energy. See, just a name, but there is nothing like rotational kinetic energy. It's just a name. The kinetic energy is still half mv square only. It is a manipulated formula which is written as half I omega square. Clear with this? Right. So since I gave an introduction of I and omega, I'll tell you all other formulae. Okay. Breathe up. Shall I proceed? Okay. So listen. Shall I do this problem? I'll do this and I'll tell you how you're supposed to handle the different formulae in this chapter with the knowledge from the previous chapters. Okay, listen to this carefully. A wheel is rotating at a rate of 1000 RPM. What does RPM stand for? Rotations per minute or revolutions per minute. So this RPM, does it give you the value of frequency or angular frequency? It gives you the value of frequency. If you want angular frequency, it should be measured in terms of radian per second. Angular frequency is in terms of radian. Frequency is in terms of number. I'll repeat it. Revolution is a number. So if the numerator is a number, it is frequency. If the numerator is radian, it is angular frequency. So F is equal to 1000 RPM. So 1000 into 1 minute. So if I want omega, right? If I want omega, then I will write it as 2 pi into F. So it is 2 pi into F is 1000 radian per, how many seconds is 1 minute? 60. So cancel this and this. This 2 will cancel this 3 times. So it is going to be 100 pi by 3 radian per second. So 100 pi by 3 radian per second is what is the angular frequency. Just a minute. One minute. Copy it. So it is 100 pi by 3 radian per second. This problem, huh? Okay. But I'll just finish it off. So kinetic energy is given as 10 power 6 joule, right? Determine the moment of inertia about its axis of rotation. How to do this? So K is equal to half I omega square. 10 power 6 is equal to half into I is how much? That's what we need to find. Omega square is, so 10 square pi by 3 the whole square. Can I write it like this? So this will be 2 into 10 power 6 is equal to I into 10 power 4 into pi square divided by 9. 10 power 4, this will cancel this 2 times. So I is equal to 18 into 100 divided by pi square kilogram meter square. This will be the answer. Clear with this? You have to actually. Pi you can simplify it as 22 by 7 and then write it. Try to bring it to the closest fraction. See, I'm not a big fan of decimals, so I'll not suggest. If your teacher is particular, you can go with it. If I correct the paper, I'm not particular about decimals. Okay. Just a minute. Oh. Got it? Okay. I'm not sure what all problems you have solved. See, mostly it will be from this slide only. You would have done this also. Did you do problems based on equilibrium of rigid bodies? Yeah. I'll just give you an outline. This one did you complete? This is your NCERT problem only. Right. Not, I suggest you guys to go and check it. This one, a ladder which is, a diagram will be like this. Done? Okay. Okay, I told you I'll tell you the technique of remembering, no? That alone you can make a note. Okay, listen. I'll draw a table for translational and rotational motion. Okay, the table for translational and rotational. Listen to this. For translational motion, what is important? Force. So force is given as F is equal to ma. For rotational motion, what is important? Torque. And how is torque given as? Listen to this carefully. Torque is called as rotational force. Mass is the measure of inertia in the case of translatory motion. You remember that? If an object has heavier mass, it is going to have more inertia. So what is the equivalent of inertia in the case of rotation? It is the moment of inertia. So wherever you have m in the case of translational motion, you can replace it with I in the case of rotational motion. In a similar way, here you have linear acceleration. Here you will have angular acceleration. So torque is equal to I alpha. Did you understand? Okay, now you'll understand it better. See, kinetic energy is equal to half mv square. So kinetic energy in the case of rotation is also kinetic energy only. Here it is called translational. So I'll just put a symbol T below it. It's called as translational kinetic energy. Here it is going to be rotational kinetic energy. Okay. So half is half only. You cannot have any substitute. So what is the equivalent of inertia in the case of rotation? So here it is m. Here it should be I. Here it is v. Here you should have angular velocity. So omega square. That is why the formula came out as half I omega square. Are you able to understand? So if at all you forget any formula in this chapter, you need not worry. You can recollect it from this chapter. Okay. So all the derivations, I've already shown it in the videos. You can go and look at it. But I'll solve the problems today. Clear? Linear momentum is mass into velocity. You tell me what should be the, for linear momentum, the counterpart is angular momentum. So L is equal to I. That's it. So it is going to be I into omega, right? Like this, you want anything you can write. So work done is equal to F vector dot S vector, or it is something like this. If I write it like this, I'm considering the variable force. So if I consider the variable force, I'll write it as integral of FDS. You tell me what will come here. Work done is the same thing. Integral is the same thing. Instead of force, what should I use? Rotational force, which is called as torque. Instead of linear displacement, what should I use there? Angular displacement is d theta, so tau d theta. This formula you'll use it more in the 12th standard. The first, second, and fifth chapter will be using this. This one. Clear with this? So like this, any formula you want, you can always write it. Okay. Those who are online, are you clear?
Yes, sir.
Okay. So with the help of this, we'll start seeing the next concept. Shall I proceed? Shall I close this? Yeah. Rotational, angular momentum. You actually have learned about angular momentum in your chemistry. Younger. What are the two Bohr's postulates? Order ஞாபகம் இருக்கடா. Dalton's theory, then came Thomson's theory came. Thomson அடுத்தது Rutherford. After Rutherford you have, what did he say? What was a mistake in Rutherford's theory that was covered in Bohr's theory? Rutherford told electrons revolve around the nucleus. That is the drawback. He never told about losing energy. Who told about angular momentum? Angular momentum is quantized. That's called Bohr's quantization condition. You have heard of this? So electrons will revolve in those orbits where the angular momentum is quantized. They speak about angular momentum. No, this is the one. This angular momentum. Okay. There are two postulates actually. One is about angular momentum, and second is when an electron moves from one orbit to another, it loses energy or it has to gain energy. So when it gains energy, you will have absorption spectrum. Loses energy, you will have emission spectrum. That's it. Right. So actually, your physics will get connected there. Right. About this, you learn in your 12th standard physics. Why that is happening. Shall I close this? Listen. This is another important concept. This one I didn't do the video, so I'll teach it in detail itself. Listen to this. So write down the heading as radius of gyration. It is represented with the symbol K. Okay. I'll first read out, then I'll explain it. Listen to this. So for any object capable of rotation, so whenever you see the word rotation, the first thing that you should ask is about which axis of rotation. Similarly, if you talk about circular motion, you should ask about which point, because circular motion will take place with respect to center, rotation motion will take place with respect to an imaginary line. That imaginary line is called as axis of rotation. In 90% of the cases, what will happen is axis of rotation will be through the center of mass only. But it is always our wish. You can always change the axis of rotation to wherever you want. Let me give you an example of what I mean by that. Okay. So listen, I have this wallet, right? Common sense. What will we do? If I have to open it, what am I going to do? I'll not think this much. I'll drop it like this. That depends on my laziness. Okay. If I want to generally open it, this is how people open it, right? Just to show you a demonstration, what are we actually doing? So here I'm applying the force and I'm making it rotate. It is getting opened, right? Now, will I apply force here and try to open it? So I'm trying to apply it, but are you able to see some difference? I'm struggling a bit. Whereas here, I'm not cheating, okay? I'm applying the same amount of force, but it is opening. But here, I'm struggling actually. I'm not able to succeed. This is happening because of the torque. So torque has a formula which states it is force into perpendicular distance from the axis of rotation. For this system, where is the axis of rotation? It is about this folding. It is about this folding only, it is rotating. In a similar way, what will you do to open the book? Same thing. You don't sit and think, where should I hold? By default, your hand goes there, you start rotating, it works, right? So this axis of rotation, by observing the symmetry of it, can I say that this is the axis of rotation through the center of mass? At least through symmetry, it is having equal shape, right? Through the center of mass. But what can happen is, if I open it, I have something over here, right? I can keep my coins. So what is happening? For this one, if you see, I'm rotating it. I'm rotating it, right? So where is the axis of rotation for this? It is somewhere over here. About this. Is this through the center of mass? So the axis of rotation can be anything, can be through any point. But most of the cases, if you look at the symmetry of this wallet, for this wallet, the axis of rotation is through the center of mass only, whereas here it is not through the center of mass. Are you able to get some perspective? Similarly, if I have a book, right? If I have a book where I want to open it, this is the axis of rotation, and I'm applying the force here. If you try to open it like this and see, you cannot open it. Especially heavier mass and all, you cannot open it. If I want to open the same number of pages, I can open it easily like this. You can try that and see later. You will find some kind of a resistance that is happening because of moment of inertia. That is why torque is related to moment of inertia. Torque is equal to I alpha. It's directly proportional. You're able to get some idea? But this book can be rotated in this way also. See what I'm doing? I'm trying to change the axis of rotation. So if I don't hold it here, if I open it like this is the axis of rotation. Whereas if I keep my hand here and rotate it, then this is becoming the axis of rotation. So why I'm talking about all this point is, when you talk about axis of rotation, there are two kinds. One is going to be the natural one. Natural one is always through the center of mass. So natural one is always through center of mass. Whereas you create something forcefully, like how I did it here, right? That is called as instantaneous. So you change something according to your convenience. Why it is done, that's a different story. That will have some purpose, right? So if you change the axis of rotation, anything other than the natural axis, you call it as instantaneous axis of rotation. So you should always ask this question of, is the object rotating about the natural axis or the instantaneous axis? Have this point in your mind. When I discuss some theorems, you will understand what I mean by this. Is it getting registered? Are you able to get some perspective of what is that axis of rotation? You're able to visualize it, right? Now, this radius of gyration is a concept which is related to moment of inertia directly. Okay. So listen to this carefully. For any body capable of rotation about a given axis, here, what do they mean by given axis? It can either be natural or instantaneous, right? It is possible to find some distance, right? It is possible to find a radial distance from the axis. It is possible to find a radial distance from the axis where, if whole mass of the object is concentrated, its moment of inertia will remain unchanged. Okay. What is the meaning of it is? I'll try to make it simple. Listen, let's take this pen. This pen is made up of infinite number of particles, right? So when this pen is rotating about this axis, right? When it is rotating about this axis, it has some amount of moment of inertia. Do you want to feel and see how the moment of inertia looks like? You want to try and see? You guys take your pen, find the center of mass. You know how to find the center of mass? You hold it like this, don't put pressure. Wherever it is getting balanced, that is going to be the center of mass, right? So hold it at that point, rotate it in the reverse direction. You know to rotate it like this. You know to rotate it like this. Right, try it. Sometimes it might fall down also, fine. You're rotating, you're able to rotate it comfortably. Any other point other than the center of mass, try to rotate and see. You take here, try to rotate and see. Are you feeling the same amount of comfort, or you're feeling that the pen is falling down? That's happening because of moment of inertia. Are you able to sense it? Are you guys able to sense it? Right, that is happening because of moment of inertia. What happened is you're able to comfortably rotate it through the center of mass because that has the least moment of inertia. Because the mass is equally distributed on both the sides. Whereas if you take any other point, then you're trying to say that the moment of inertia is more on one side. So whichever side it is heavier, right, it will fall on that side. You cannot comfortably rotate it. So you're changing some other axis of rotation. Now this is what is called as instantaneous axis of rotation. Now listen to this carefully. When I rotate it about this axis, it has a moment of inertia associated with it. Let me call it as I. So I'm calling this moment of inertia as ICM, but that is a moment of inertia through the center of mass. Okay. Now the question is, if I replace this whole mass with a point mass, right? See, this is my pen, approximately. This is the axis about which it was rotating. So about the same axis of rotation, what I'm doing is, I'm replacing this whole pen with a point mass. I'm replacing the pen with a point mass whose value is the same as the total mass of this pen. So if I take this pen and put it on a weighing scale, let's say it is showing few grams. I'm replacing those few grams. I'm taking a small stone and keeping it here, which is exactly of the same mass as that of this pen, right? Now, when this pen is rotating about this axis of rotation, right? Let's say its moment of inertia is ml square by 12. Okay, some number ml square by 12, where m is the mass of this pen, L is the length of this pen, and 12 is the number you're getting after finding all the values. Don't worry how it has come. Okay. Now, what did I do to that pen? I replaced it with a stone exactly of the same mass. Now, the question is, at what distance should I keep the stone from the same axis of rotation to have the same moment of inertia of ml square by 12 is what the question is. Listen to this carefully. I'm taking the stone and keeping at a distance k, where this k is what is called as radius of gyration. So if I take the stone of mass m and keep it at the distance k and put it into rotation, then the moment of inertia of the stone will also be ml square by 12. Then this distance at which you put that stone to make it rotate is what is called as radius of gyration. Actually, this concept was introduced to bring in a generalized formula, which we'll be learning later. If you see, there is something called as rolling motion. In that rolling motion, we need to derive something called as general formula. We'll derive a general formula where we'll be using this K. Are you able to understand the significance of it? Are you able to understand? So to put it simple, if you have, this is called as an extended object. Extended means it has a finite shape, finite length associated with it. So if you replace the extended object with a point object, where should that point object be placed? At what distance the point object should be placed from where? From the axis of rotation, from the same axis of rotation to generate the same moment of inertia is what is called as radius of gyration, right? So what is the moment of inertia of this pen? It is ml square by 12, right? So it is ml square by 12. So mathematically, this value should be equal to, now what mass is this? This capital M. Is this a point mass or an extended mass? Point mass, because he replaced this pen with a stone, small stone, which has the same mass, right? For point mass, I already gave you the formula for moment of inertia. Can you check and tell me? I told you moment of inertia is defined only for point mass. And what is the formula I gave? Mass of that object, mass of the object into distance square. So here, what is the distance at which it is kept? K square. K, no? K is the radius of gyration. So M and M will get cancelled. So K will be equal to L divided by root 12. So what is the meaning of this? You take that stone of mass M and keep it at what distance? Keep it at a distance of L by root 12 to get the same moment of inertia. Are you able to understand? See, even if you're able to get some idea, you're still good. How we can? That you forget, I told you, no, I'll teach you. That is some number. So if that is a moment of inertia, did you understand what is the radius of gyration? This ml square by 12, I'll teach you, don't worry, that's my headache. Did you understand this concept? Right? So This is all about the concept of radius of gyration. So what are you doing? What are the steps you are following? You will convert an extended object to a point object. You will not change the axis of rotation, right? From the same axis of rotation as that of the extended object, you will place the point object at some distance so that what should match? What values should match? The moment of inertia of the point object and the moment of inertia of the extended object should exactly match. If they match, then the distance at which you place that point object is what is called as radius of gyration. Okay. Those who are online, did you understand?
Yes, sir.
Okay. Come again. Is there a size of the? It is independent. No, mass is independent. It is only dependent on the distance. Okay. So there are two things important for you to understand. You need to understand what is the radius of gyration, and you need to understand how to calculate radius of gyration for any object. That I'll teach you first. Don't worry about these numbers. Don't overthink about them. There is a small derivation for that, which I'll teach later. Let me know once you're done. Shall I proceed? I'll come to this one later. Okay. Now, I'll give you the values of moment of inertia of certain regular objects. Do you all have textbook with you? Right? Can you just open it? There is a table given in it. So moment of inertia of all the regular objects. It is in page number 165. New book or old book? Older. Old book, it is in page 165. Not sure of the new book. Those are online. You can tell me in which page the table is given. You will. In the new book, I'll inform them. New book, ada? Book liya. Okay. So I'll do one thing. I'll read it out from here and I'll directly give you the value. I'll show you the derivation only for one, because the derivation is not important for your CBSE, of course, for your entrances also. Okay. But I'll teach you the method of how things are derived. Okay. Listen to this. So whenever you talk about rotation itself, what is most important? Rotation word comes. First question you are supposed to ask. Axis of rotation. So if somebody asks you a question, tell me the moment of inertia of a ring, it is meaningless. What is that you're supposed to ask? About which axis are you asking? Right? So listen to this. So moment of inertia of a thin circular ring in the sense, generally a ring will have some amount of thickness, but the thickness is ignored. Okay. So if that ring is rotating about an axis passing through the center, right, about an axis passing through the center, then what is the moment of inertia of this? The moment of inertia of this is given as m r square. Is that value given? So it is m r square. So moment of inertia of a ring about its center of gravity, about an axis passing through its center and perpendicular to the plane is going to be m r square. Okay. So what I want you to write is this thing. Right, just make a quick note because it's already there in your textbook. Okay. So you can write it like this, put a table, object, axis of rotation, moment of inertia. So first object, what did we see? We saw for a ring. What is the axis of rotation? Center, and this is important, perpendicular to the plane. Center and perpendicular to the plane, the moment of inertia is mr square. Okay. Shall I proceed? So write it in this format, object, axis of rotation, moment of inertia. First one, ring, center and perpendicular to the plane, it is mr square. Okay. So below that, leave some space. Below that, leave some space, at least 2 lines, leave it. Then write for the next one. Shall I proceed? Yeah. Now see, I'm not telling you about the diameter. The next is moment of inertia of a uniform circular disc. See, when you think of a circular disc, what can you give me an example of a circular disc? Frisbee. You can think of a CD. Frisbee is also there, but it has slight thickness. Because here we are using uniform circular disc, its thickness is less. Okay, you can think of a CD, right? CD where the center part is also there. Only then it will become a uniform disc. For this, the moment of inertia about the same axis, about an axis passing through the center and perpendicular to the plane, means if the CD is like this, the axis of rotation is like this. It is rotating in this way. The CD is rotating like this. Okay. Imagine that CD rotating inside that player. Will rotate, no? So the axis of rotation is like this. Okay. So for that, the moment of inertia is mr square by 2. It is mr square divided by 2. Write down the values. Don't think. Just write down the values. There is a reason why these values have come. Write it down, please. mr square by 2. Same axis. So center and passing through the center and perpendicular to the plane. Center and perpendicular to the plane. So leave 2 more lines. Okay. Next. Next is moment of inertia of a thin uniform rod. If there is a rod which is thin, means its thickness is ignored and it is rotating about its center of mass, then the moment of inertia of this object is going to be, this is where the value is ml square divided by 12. It is ml square divided by 12. Through the center and perpendicular to the plane. See, here you will have it, okay, about a perpendicular axis through its center. So it is ml square by 12. Again, leave 2 lines. Okay. So now I'll go a little fast because I'm telling you the values. Just write it down. So moment of inertia of a cylinder about its own axis. So if the cylinder is like this, it is rotating in this way. If the cylinder is rotating like this. So this is going to be the axis of the cylinder. So the moment of inertia of this is going to be of a hollow cylinder, right? So when you talk about cylinder, right, there are 2 types of cylinders we can talk about. One is a hollow cylinder and one is a solid cylinder. So for a hollow cylinder, it has the same value as that of the ring. So for ring, what was the value? Mr square. For hollow cylinder also it is Mr square. Okay. Just give me this one, the book. Yeah. So for hollow cylinder, it is Mr square. So below that you can write for solid cylinder, it is, see, this is for hollow cylinder. For solid cylinder, it is Mr square by 2. So solid cylinder will behave like a disc. Hollow cylinder will behave like a ring. Okay. Clear with this? Again, leave 4 lines. Next is a solid sphere. So for a solid sphere rotating about its center, right? So you can write it like the solid sphere about its diameter. Solid sphere about its diameter. The answer is, see, for solid sphere, the answer is 2 by 5 Mr square. And for hollow sphere, it is, and for hollow sphere, it is 2 by 3 Mr square. 4 lines, just 4 lines. Okay, konja space vidu. In your book, they have not given it for hollow sphere. Solid sphere is the last, because that's what is given in the problems also. But for hollow sphere, it is 2 by 3 Mr. You can remember that, okay? Right. Now, as I told you, I'll explain one derivation, right? Post which the same kind of process is applicable for all others. So I'll explain for this rod. Okay. Now listen. Did you all attend the class of center of mass? I told you how to find the center of mass for extended object. I gave you some steps, right? So first, what is the step? What is the first step? Check your notes. You were there, Lida. Notes in. Where note? N particle, extended mass. Integration course steps. 5 steps. I told about different kinds of mass densities. Nearly on the class. Okay. See, there are 3 kinds of mass densities. There are 3 kinds of mass density. One is called as linear mass density. Then we have surface mass density. And we have something called as volume mass density. So it's called as volume mass density. So linear mass density is represented by the symbol m divided by L. Okay. And surface mass density is defined as the amount of mass per unit area. And volume mass density you had been learning since your lower grades, which is the mass per unit volume. Okay, these are the three kinds of mass density. Okay. Just write down fast. Shall I proceed? Listen. When I told you the formula for moment of inertia, what did I tell you? The first statement, it is applicable only for point masses. It is applicable only for point masses. See, suppose this is the axis of rotation. If there is a point mass kept here, which is at a distance r, then the moment of inertia of it is given as m r square, mass into distance square, correct? Now here, we don't have point mass. We have extended mass. See, what is that we are trying to do? Did you understand the objective? You have a thin rod. The thin rod is rotating about about an axis passing through the center, right? So for this, what we are supposed to do is, first step is define the type of mass density. See, when the thickness of this rod is going to be very, very small, right? Can you consider it like a linear surface? So the name itself is suggesting if it is a linear surface, what kind of mass density should be considered? Linear mass density. So linear mass density is m divided by L. So it is m divided by L. Second step is, since I know that the moment of inertia is applicable only for point mass, and here I have extended mass. So converted to point mass means I need to break the system into infinite number of small particles. So what I will do is, I will consider a small element, right, of thickness dx and mass dm, right? And I'll consider this mass at a distance of x from the axis of rotation, because I'm only looking at the formula. So for me to apply the formula, I need to know two things. What is it? What is the mass that is rotating? And how far is that mass from the axis of rotation? I did both. So in this case, out of the infinite number of masses, one of the masses I considered is, one of the point masses is dm. So whenever you use that d, right, as a suffix, sorry, as a prefix, it becomes very, very small. It becomes a point mass. So here the point mass is dm, and at what distance is it present? It is at a distance of x. It has a thickness of dx. So dm has a thickness of dx. Since I told you d is a prefix, means it is very, very small. So it will become a point mass. Okay. So what I'm going to do is, second step, I'm going to define the moment of inertia of the point mass. So moment of inertia of the point mass is also going to be small, because that is why I wrote di. So di is equal to, what is the formula? Tell me, in the place of m, what should I replace with? dm. In the place of r square, what should I write? Very good. So dm into x square, that's it. Now what I need to do is, I need to write dm in terms of m by l and x. Are these two steps clear? Okay. Now what I'm going to do is something like unit. You know what is unitary method, right? What is it? Cross multiplication, basically. See, if one item is costing this much, you want to buy multiples of it. You'll just cross multiply and solve it, right? In a similar way, this total rod has a mass of capital M. Listen to this carefully. This rod has a mass of capital M for what length? For length of L. So this dm is a part of this capital M. So dm will be the mass for a length of dx. Are you able to understand this? So if the total length of the rod is length L and it has mass capital M, then in thickness dx, how much mass is present? In thickness dx, dm mass is present. Right? So cross multiply, then you will get dm is equal to m by L into dx. So this is the third step. What is it? dm is equal to m by L into dx. Fourth step is, take this and substitute it here. When you substitute it here, di will be equal to m by L into x square dx. Right? See, generally when you integrate it, I have to tell you, when you want to eliminate the d, right? You need to integrate. So that is a fifth step. I is equal to, listen to this, this is the part we need to be careful. M by L into x square dx integral from where to where? This is where we need to be careful. See, since you took the center to be the axis of rotation, from the center, how much rod is present? See, the total length is L. If the total length is L, from the center, how much mass is present on the right hand side? Sorry, how much length is present on the right hand side? L by 2. How much length is there on the left hand side? L by 2. So, if I take this point to be the origin, imagine this to be x axis, then can I say the coordinate of this point will be minus L by 2 comma 0? Can I say the coordinate of this point will be plus L by 2 comma 0? So where should I write the limit of integrals from? If I want to cover the total rod, where should the value of x start from? Minus L by 2 to minus L by 2 to plus, this is what you told? Okay, sorry. I heard it as 2 L by 2. So minus L by 2 to L by 2. Is it clear? Now we are done. Did you understand the steps? So what is the first thing? For anything, for any kind of an extended object, first step, what is that we did? We defined the mass density. So if it is a one-dimensional object, define linear mass density. Two-dimensional surface, three-dimensional volume mass density. Okay. Second step, by default, write the formula. So second step is on the shape, consider dm, dx, and x. From where x will be considered from where? X is the distance from the, it's from the axis of rotation to the place where you considered the mass. And the thickness of that mass should be dx. Clear? And what is the third step? I mean, third in the sense, not this one. Okay, a part of the second step itself. After you consider this, di will be equal to dm into x square. Where did we get the idea from? The basic formula of I is equal to mr square. So is the second step registered? Third step. Use unitary method. Use unitary method and find dm in terms of x. Dm in terms of x and then write it. That is the third step. What is the fourth step? Substitute 3 into. After you substitute 3 into, di will be in terms of dx. Fifth step is integrate with proper limits. Okay, so here I hope you understood how to take the limits. Right, I'll take the L, m by L outside. M by L into, what is the integral of x square dx? X cube by 3. Between which two limits? Minus L by 2 to L by 2. I hope everyone is clear with understanding definite integrals. Right, I can take the 3 outside. M by 3L into, if I substitute L here, it will be L cube by 8 minus L cube by 8. ஸ்கூல்ல இதுயா இந்த கான்செப்ட் சொல்லி கொடுத்தாங்க. Oh, this sum they gave. Oh, okay, okay. So this is m by 3l, m by 3l into L cube by 8 minus of minus is plus. So L cube by 8 plus L cube by 8. 2L cube by 8, which is L cube by L will cancel this 2 times. So ml square divided by 3 into 4 is 12. That is why the value came. Got it? Now you understood. So that's how it works. Right? See, the steps that I gave you is algorithm you need to follow everywhere. I'm telling you, wherever integration is followed in physics, these are the steps. Only thing is, it will vary from chapter to chapter. In a chapter, if you're dealing with mass, you will write dm. If you're dealing with charge, you will write dq. If you're dealing with something else, on the parameter, that parameter alone will change. But the steps are the same. Okay. So I am telling this is don't get scared looking at integration. Steps are same. You're done? Those are online, could you understand? Is every step clear to those who are online?
Yes, sir.
Ananya, Kavya, Kirtana?
Yes, sir.
Yeah. Chitesh, are you there? Let me know once you're done. Done. See, suppose, okay, just to understand, if I change this axis of rotation to one of the ends, okay, what I'm doing is, where is axis of rotation in this case? If I treat it as it's at the center. If I shift it to one of the ends, then do you think the same value will come? Obviously, no, it cannot come, because moment of inertia clearly tells you that the distribution of mass is dependent from the axis of rotation. So when you hold it at the center, equal mass is distributed on both sides. Whereas if I shift the axis of rotation to the left extreme, for instance, what you told is right. If I shift it to the left extreme, my question is, logically tell me, should the value come out to be greater than ml square by 12 or less than ml square by 12? Let's see how many of you understood. Use logic, okay? Dirk, let's say pen is hinged here, the pen is rotating like this. See, now it is rotating like this about the center. Whereas in the next case, it is rotated like this. You try to rotate and see. 3 okay. But you calculate it. Now, calculate panasula. You told 3 is correct. But use a logic and tell me, should the moment of inertia increase or decrease? Why should it increase? Because more mass is concentrated on one side. So more is the moment of inertia, it is more difficult to put it into rotation. Okay. So your value should come out to be greater than ml square by 12. And if you calculate it right, it will come out as ml square by 3. That's what value is correct. Do you understand that? It will come out as ml square divided by 3. Listen, I'm going to just calculate and show you. So only difference is, see, you understood the whole algorithm, right? So which step will change? Only the 5th step, limits will change. Till there, everything is same. So I should be equal to integral of what should be the change in the limits I should write? 0 to L, and it is going to be m by L into x square dx. So it will be m by L into what is x square dx? Integral. Same L cube by 3. So L cube by 3 between 0 to L. So substitute the upper limit. I'll take out 3 outside, m by 3L into L cube minus 0. So it is m by 3L into L cube. This and this will get cancelled. This ml square by 3. Since the denominator has reduced, the value will increase. What mistake we'll do is, we'll think that ml square by 3 is less than ml square by 12. No. Ml square by 12, the denominator is more, value is less. So what is the meaning of this? More is the moment of inertia, tougher is the object to be put into rotation. So these are all the significance questions that they might ask you. Be careful with that. Okay, write it down. What is the time? 6? 5, 7, 58. Okay. Did you understand? See, every time you need not do this kind of a complicated process. To find the moment of inertia directly in 2 steps, right? There are 2 important theorems. One is called as, I was supposed to teach today. One is called as, 1 minute. No. Parallel axis theorem, and the second one is called as perpendicular axis theorem. I'm not going to show you the proofs for these things. I'll tell you how to apply it. Okay. So this we'll see in tomorrow's class. Then we'll go to the concept of rotation of an object. With that, we are done with this chapter. Okay. And tomorrow's class will be slightly important because more problems based on moment of inertia will be solved. Okay. Yeah. So revise and come. If not everything, at least go through the concept of moment of inertia, which I've taught in the video and come. It is in the module 2 under the video section. Okay. Just go through that and come. I hope it is clear, right? Any questions? Okay. Then wind up. Those are online. Any questions? Ananya, Kirtana, Shweta?
No,
All
sir.
clear? All clear? Okay. Okay. We'll wind up.
Thank you, sir.
Thank you,
Yeah.
sir.
Yeah.
Thank you, sir.